All right, let's dive into something pretty cool today. Something that could seriously change how we work with AI.
Yeah, we're going to be looking at a new way to make large language models, those AI brains behind chatbots and all that, think way more efficiently.
We're talking about a new technique, right?
Right. It's called Chain of Draft, COD for short, and we've got some research papers and briefing docs about it that are really interesting.
Before we get into COD, can you remind us, what's the problem with LLMs to begin with? I mean, we hear about how amazing they are all the time, but there's got to be a catch, right?
Well, yeah, you're right. LLMs are capable of crazy things, writing stories, translating languages, you name it. But they tend to kind of overthink.
Overthink?
Yeah, like imagine trying to explain something super simple to someone who just keeps asking why over and over. That's what LLMs do. They generate tons of text, even for basic stuff, and all that processing takes up a lot of time and computing power.
So it's like they're writing a novel when a quick text would do.
Exactly.
Hmm.
And that's where chain of thought prompting comes in, CTU.
Right, so AT. I've heard of that.
So with OA, you guide the LLM to explain its reasoning step by step, so we understand how it got to its answer, like showing your work in math class. But the thing is, even though it's helpful, COA can lead to some seriously long responses.
And I'm guessing that's where code comes in, right? This more efficient alternative. What makes code so different?
Okay, think about how you take notes. You don't write down every single word, right? You filter stuff, You prioritize and summarize. Code works kind of like that. It tells the LLM to give shorter, more concise responses. And get this, these shorter answers can be just as accurate as COTI, but way faster and cheaper to compute.
So it's like teaching the AI to be more like us. Get to the point, no need for the whole essay. Can you give us an example of Co in action?
Sure. The researchers used this simple problem about lollipops to show the difference between standard LLM responses, COT, and code. So picture this. There are 20 lollipops, and some are missing, leaving only 12. The question is, how many are missing?
Okay, pretty straightforward. How would a standard LLM tackle this?
A standard LLM would just spit out the answer, 8, with zero explanation.
What about with CoT?
CoT, on the other hand, would walk you through each step, like 20 minus something equals 12, and then solve for the missing number. Accurate, but wordy.
Okay, hit me with the code response. What's that look like?
Much more to the point. It might be something like 20x equals 12, x equals 12 equals 8. Hashtag, tag, 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 8, just the key steps in the answer, all nice and compact.
Interesting. So it's like a shorthand for thinking, right? Focusing on the important stuff. But how do we know this works for more than just simple math problems? Different kinds of reasoning.
Good question. They actually tested code on various tasks. Arithmetic, common sense reasoning, even symbolic reasoning.
Symbolic reasoning. That sounds pretty complex. What does that even involve?
Okay, imagine figuring out the state of a light switch after flipping it a bunch of times. The starting point and then a sequence of actions like flip the switch, flip it again. Symbolic reasoning means understanding how each action changes the switch's state and figuring out the final state. It's all about the logic. No need to picture every flip.
Gotcha. So how did COD do with these tougher tasks?
Really well, actually. Across the board, COD used significantly fewer tokens and had much lower latency.
Hold up. What are tokens again?
Think of them like the individual units of language an LLM works with. Words get broken down, punctuation is a token, all that. Shorter response means fewer tokens, which means less work for the AI.
Right, right. And latency.
Yeah.
How much faster are we talking?
In one test, using a dataset called GSM-8K, a bunch of grade school math problems, COD was a whopping 80% faster than code.
80%. That's huge.
Yeah, and it wasn't just math. COD was faster with other types of reasoning, too. It's got the potential to really change how LLMs handle information.
So it sounds like COD isn't just some theory. It could actually make AI faster and more efficient in the real world.
Yeah.
But how does this affect, us regular folks? What's the connection between COD and the tech we use every day?
Imagine your chatbot summarizing a long news article in just a few sentences. Or your AI assistant explaining a complicated piece of code super clearly and concisely. COD could be the key to making those things a reality.
So we could be looking at faster search results, better chatbots, even more efficient coding tools, all thanks to COD. That's pretty exciting. But, before we get too carried away, I'm sure there are some potential downsides too. Every new tech has its challenges, right?
Oh, definitely.
Well, we'll get into those in the next part of our deep dive. Stay tuned. We're back, diving deeper into Chain of Draft, Last time we were talking about how COD could lead to faster search results, better chatbots, and all those awesome improvements in AI tools.
Yep, and you know what I find really fascinating about COD? It can not only make AI more efficient, but also more like how WE think and talk.
So instead of just teaching AI to be like us, we can actually learn from AI and make our own thinking more efficient.
Exactly. Think about it. We're bombarded with information all the time these days, right? Being able to filter, prioritize, and boil it all down to the essentials. That's becoming more and more important. And COD shows us how AI can be amazing at doing just that.
It's like AI is giving us a crash course in efficient thinking. Now, you mentioned earlier that the researchers tested COD on different kinds of reasoning tasks. One that stood out to me was that big bench benchmark. It's all about testing an AI's common sense reasoning, right? Can you tell us more about what kinds of tasks that involves?
Sure, Big Bench has this whole range of tasks that assess how well AI understands and reasons about the world, in a way similar to humans. For example, one task might involve understanding dates, like you tell the AI John's birthday is next Tuesday and today is Friday, and then you ask it to figure out what day John's birthday is on.
Sounds simple enough for a person, but I bet it's a bit tricky for an AI.
You got it. It needs to understand the days of the week, but also the whole concept of a birthday and how it links to a specific date. COD did surprisingly well with stuff like that. Showed it could process information efficiently and get the right answer without getting lost in unnecessary details.
So COD can handle calendar calculations. What other common sense reasoning tasks were they testing?
Well, there was another one that involved understanding sports. So imagine the AI gets a short description of a game and then has to figure out who won based on what happened. And again, COD was really good at this. It could quickly figure out the key players and actions that decided the game.
Interesting. It's almost like a COD is helping AI develop a sense of what's really important in the situation, not just processing, but understanding the meaning and zeroing in on the crucial details.
Exactly. And that ability to prioritize and cut to the chase is what makes COD so exciting. It's not just about speed or cost, it's about making AI smarter in a way that aligns with how WE think and solve problems.
Now, you also mentioned symbolic reasoning tasks, right? Where the AI has to work with abstract symbols and rules. Got any examples of what that might look like?
Okay, imagine you have a set of colored blocks, and there are rules about how you can stack them. Like, say, a red block can only go on top of a blue block. A symbolic reasoning task might involve giving the AI a starting arrangement of blocks and then a set of instructions like put a green block on the red one or move the yellow block to the bottom. The AI has to figure out the final arrangement based on the rules and instructions.
That sounds pretty tough, especially for AI. How did Khan handle that?
Surprisingly well, actually. It solved those kinds of problems with a high degree of accuracy, showed it could understand and apply those abstract rules.
So not just arithmetic and common sense, but COD can handle abstract symbolic stuff too. It really seems like this technique could revolutionize a ton of AI applications.
It really does. And one of the things that's super interesting about CARD is that it makes us wonder if AI could actually teach us something about how to think more efficiently. If AI can learn to focus on the most important information and get to solutions faster, could WE adopt similar strategies?
It's a really cool thought, isn't it? Like AI is holding up a mirror to our own brains and saying, hey, maybe you could be a little more concise and efficient too. Now, while we've been focusing on the good stuff about COD, I think it's important to remember that there are some potential challenges and limitations too.
Oh, for sure. Every new tech has its complexities, and COD is no exception.
Welcome back for the final part of our deep dive into Chain of Draft. We've spent the last two parts talking about all the awesome potential of this technique, but like you said, every new tech has its challenges. What are some of the things we need to be careful about with COD?
Well, one thing that comes to mind is the risk of oversimplification. If AI gets too good at summarizing and cutting to the chase, could we end up missing important details, the kind of details we need to make good decisions?
That's a good point. Conciseness is great, but sometimes you need a more detailed explanation to really understand something.
Right, exactly. Think about a medical diagnosis. You wouldn't want a doctor to just say, you're sick, take this pill.
No,
Right.
definitely not. I'd want to know what's wrong with me, why the doctor thinks that, and what the side effects of the medicine might be.
Exactly. So it's about finding the right balance between being concise and giving enough information.
So how do we make sure code doesn't sacrifice accuracy or, being thorough just to be more efficient?
That's a big question researchers are working on. It's about figuring out when a short answer is enough and when we need more details. And it's also about making sure those summaries code creates are faithful to the original information, that nothing important gets left out or distorted.
So we're not just teaching AI to be concise, we're teaching it to be smart about when to be concise.
Yeah, it's got to understand when to keep it short and when to go deeper, depending on the situation.
Another thing that worries me is transparency. If AI is doing all this thinking in the background, how can we be sure its reasoning is sound and unbiased? It's like a black box. How do we know what's going on inside?
Transparency is super important, especially as we start using AI for more and more things. Researchers are trying to find ways to track the reasoning process of COD systems, kind of like leaving a trail of breadcrumbs so you can see how the AI got to its answer.
So it's like an audit log for the AI's thought process, making sure it's not skipping steps or being biased.
Yeah, exactly. It's all about making sure we can trust the AI's decisions.
Throughout this deep dive, we've been comparing how AI thinks to how humans think. But even with something like COD, which tries to make AI more human-like, there's still a big difference between the two, right?
Absolutely. We humans, our intelligence comes from a lifetime of experiences, emotions, values, all that stuff shapes how we see the world. AI, at least for now, doesn't have that same depth. It can process information and learn patterns, but it doesn't really get context, nuance, or the bigger picture the way we do.
So even though code is a really cool step towards making AI more efficient and more like us, it's important to remember it's still just a tool. And it's up to us, the humans who build and use these AI systems, to make sure they're used ethically and for good.
I couldn't agree more. As AI keeps getting more powerful, especially with techniques like code, it's super important to talk about the ethical side of things, the potential risks, and how it all affects society.
Well, this deep dive into Chain of Draft has been fascinating. It definitely seems like it could change how we interact with AI in a big way. But like any powerful tool, we got to approach it with a healthy mix of excitement and caution. See the potential, but also be aware of the risks and make sure it's developed responsibly.
I think that's a great way to put it. And it's something we all need to work on together. Researchers, developers, policymakers, even the public. We need to make sure AI benefits everyone.
Thanks for joining us on this deep dive.
Mhm.
And to everyone listening, keep exploring, keep asking questions, and keep pushing the boundaries of what's possible.